An ellipse is a set of all points x and y in a plane, the sum of whose distances from two distinct fixed points, called foci, is constant. So when I add the two distances that we have here in red together, no matter where this point xy is on the outside of this, it's always going to be the same distance. So if you almost think of these two pieces as being a string, and these two being kind of nailed down, as we kind of move this point around and stretch that string so that these two sides are different lengths, it's going to change. It's going to change where that point is located. However, that string is always going to stay the same length. Now, it forms something called an ellipse, and our ellipse has different parts to it. So, unlike a circle, an ellipse is like a squished circle where we don't have the same diameter in every direction. So, we have the shortest and the longest. So, our shortest, if you want to think of it as a diameter, is called our minor axis. And our longest, again, if you want to think sort of diameter, is called our major axis. And like a regular circle, we do have a center. Each of our points that are on the ends here of our major axis are our vertices, really the vertices of the major axis. And then we have, like I said, we have our major axis, our minor axis, and we have that center. We do have two ways of writing the equation here. And really all that's changing, I know it's a little small, but if you notice, all that's changing in these two equations is A and B, where their locations are. So we have x minus h squared over a squared plus y minus k squared over b squared is equal to 1. So what do those things stand for? Well, first of all, if we take a look, A is going to be half of the major axis, basically like the major radius, if you want to think of it that way. And B is going to be the shortest radius, if you want to think of it that way. So that 2A and 2B is the diameter, really. It's like double the, if you want to be thinking kind of like circles, if you want to think diameter, if you want to think radius, that's kind of the equivalent there. So depending on which way the shape is kind of squished, if it's long left to right or if it's extra tall, that's going to change what A and B are going to be. But the A, or the part that is going underneath the X here, is always going to be the horizontal measurement, and the part that is going under the Y is always going to be the vertical measurement. So that makes it a little easier, especially if we're looking at the picture, to kind of figure out what's going on here. We also have a special rule, and the special relationship kind of between that A and B here with an ellipse is that A squared minus B squared is equal to C squared. Okay. So that's just kind of a nice trick. C, however, we're going to talk about in a little bit, is going to be the distance having to do with the foci from the center to each focus. So C is the distance from the center to one focus, or the foci, or foci, some people say. So to measure if you want to think of it as ovalness, how much of an oval versus closer to a circle, we have a special measurement that we can talk about, and it's called eccentricity. The eccentricity, or E, of an ellipse is going to be given by the ratio of the C, the distance from the center to the foci, divided by A, the major radius, if you want to think of it that way. So we want to note that with an ellipse, it's always going to be between 0 and 1, that measurement. Okay. So here we go. Here's our foci, or our foci, which are kind of our fixed points that we were saying is how we draw our ellipse. When they are really close to the center, my shape looks a lot like a circle. When they are further from the center, further apart, then it's more and more like an oval. Okay. So what we can do is find the standard form of our equation, which was those fractions from before, having been given certain information. So here we are given the the foci coordinates, and the length of the major axis. So remember, we have our shape. So let's plot those points that were given. That might actually help us a little bit here. So we have the point 0, 1. We have the point 4, 1. Now our foci are symmetric to the origin. So if I find the midpoint between them, that's going to, or not origin, the center of our ellipse. So if I find halfway between them, that is going to give us the center. So if these are, I'm going to put just a little F so we remember that's what they are. Our center should be halfway in between. We could use the midpoint formula here to figure that out, or, I mean, we can pretty much eyeball it. But if we weren't sure, to get the center, it's really just the average. So we'd say 0 plus 4 divided by 2, comma, 1 plus 1 divided by 2. And that would give us the center point of 2, 1. So I'm going to put a little C for center. Actually, maybe let's just leave it as is. That way we don't get confused with the other state. All right, so from here what we want to do is we also know the length of the major axis. So the length of our major axis is always going to go along with the foci. So we have, our length is 6 of the major axis. That means from the furthest left to the furthest right. That's really like our diameter here. So if our major axis is 6, that really means that 2A is equal to 6, which means that A is equal to 3 in this case. So we can kind of count from the center out 1, 2, 3 points. 1, 2, 3 points. And those are going to be the endpoints of my major axis there. All right, so the last thing we want to do is find B, and then we can write our formula. Remember, we said before we had a special rule that A squared minus B squared is equal to C squared. We actually do know C. It's the distance between the center and the foci, which is 2 here. So C is equal to 2. So that gives us 3 squared minus B squared is equal to 2 squared. So that is 9 minus B squared is equal to 4. Let's see, negative B squared is equal to negative 5, or B squared is equal to positive 5. So B is the square root of 5. Okay, the square root of 5. So let's write our formula. So we have x minus h. Now h and k are really the center here, and I should have said that before. So the center is 2, 1. That's my h and my k. So we're going to have x minus 2 squared over a squared, our horizontal measurement, which is 3 squared, plus y minus 1 squared over, and we have the square root of 5 squared, and that's going to be equal to 1. Now, if we wanted to continue drawing this, I would just need to know how far up and down to draw this root 5. So I would go whatever the square root of 5 is up, whatever the square root of 5 is down, and there's my ellipse. All right, here's my equation. All right, let's take a look at the next one. We're going to sketch this ellipse. We know that we want this to always say equals 1. So we're going to divide by 36 to make that happen. All right, so on the right-hand side, I have 1, which is my goal. 4x squared over 36 is going to give us x squared over 9, plus, and that's y squared over 36. It may be helpful to write these as a squared and b squared, though. So that's x squared over 3 squared plus y squared over 6 squared is equal to 1. All right, so remember, this is the horizontal measurement from the center. This is the vertical measurement. All right, so we know that our center, h and k, would have been our center, which really means in this case it is 0, 0. And we want to go horizontally 3 spaces in both directions. Oops. 1, 2, 3. 1, 2, 3. And I want to go vertically 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And there is my ellipse. Then we want to graph the ellipse given by this equation here. Now this equation is not in that standard form. I do need to put it into that standard form, so we're going to have to do some completing the square here. All right, so the first thing I want to do is get my constant or constants over to the right-hand side. So I'm going to subtract 9 from both sides. And then what I want to do is make sure that I'm grouping things together. So I'm going to put all the x's together and all the y terms together. So I have x squared plus 6, and I also have a positive 4y squared minus 8y, and that's going to equal negative 9. Okay. So my goal here is to complete the square. So I want to make sure that my squared term has no number on it. So if I do, I'm going to factor it out. With the x, I don't. I'm going to leave this gap on purpose. Plus, I'm going to factor out that 4 from the y's. Again, I'm leaving that gap on purpose. And I am going to complete the square. So what completing the square is going to do for us is that it is going to turn these into perfect square trinomials that I will be able to write as x plus something or minus something squared. Okay. And then I'll have plus 4. Here I'll be able to do y minus, because there's a minus in the middle, something squared is going to equal the other side. And then I have perfect square trinomials. Okay, so to both sides, remember with completing the square, what we want to remember to do is half it, square it, add it. So what I mean it is we're going to take that middle term, we're going to cut it in half. 3, we're going to square it. 9, we're going to add it to both sides. That is going to give us x squared plus 6x plus 9, which is x plus 3 squared. If I were to FOIL that, I would get x squared plus 6x plus 9. All right, for the other one, I want to do the same thing. I'm going to take that negative 2, cut it in half, get negative 1. I'm going to square it, get positive 1, and I'm going to add it. But when I add it to both sides, I'm not really adding positive 1. What I'm adding is 4 times positive 1. And that's because of that number on the outside there. All right, now we can clean this up. So that's y minus 1 squared. On the right-hand side, negative 9 plus 9 plus 4 times 1 is going to give us 4. And then just like we did in example number 7, we're going to divide by that number on the right-hand side. So that's going to give us 1, which was the point of doing that. We have x plus 3 squared over 4, or you might want to write it as 2 squared. Here the 4's will cancel, so we have y minus 1 squared over 1. So now for HK, remember we're changing the sign here, so we're actually going negative 3, positive 1. 1, 2, 3, positive 1. We're going to go horizontally 2 spaces, and vertically 1 space. And there's my ellipse with a center of negative 3, 1.